In this module, you will learn the principle and working of a Van de Graaff generator.
What you saw was no magic. It happened because this machine, known as the Van de Graaff generator, produces a charge which travels on to the person who touches it. The charge acquired by each hair is same, so they repel each other. Due to this repulsion, they all stand on their ends.
Robert J. Van de Graaff in 1929 designed the Van de Graaff generator to generate electrostatic charges up to 10 to the power of 7 volts for experiments in nuclear physics. A Van de Graaff generator has a belt of an insulating material that carries charge, a lower pulley and an upper pulley on which the belt moves, an electric motor to rotate pulleys, a spray comb near lower pulley to spray charge on the belt, and a collector comb near upper pulley that collects the charge from the belt, and a hollow metallic sphere on which the charge is transferred from the collector comb. When the motor of the Van de Graaff generator turns on, the belt moves up. As the spray comb is maintained at a positive potential, its field strength around sharp-pointed edges exceeds the breakdown field strength of the medium. Thus, the high surface charge density around sharp-pointed edges produces a discharge known as Corona discharge, and the repulsive action of similarly charged ions deposits the positive ions on the moving belt. The moving belt carries the positive charge inside the hollow sphere. The high electric field created inside results in another Corona discharge. It causes the positive ions to move towards the collector comb, while the negative ions neutralize the charge on the belt. In this process, the collector comb keeps collecting the charge, and as the net charge inside the hollow metallic sphere is zero, it transfers the positive charge to the outer surface. As the charge on the hollow metallic sphere keeps on accumulating, its potential increases too. The charge then leaks into the medium after the limiting value of potential. This leakage can be minimized if the generator assembly is housed inside a sealed chamber filled with nitrogen or methane gas at high pressure. Van de Graaff generator is used as a particle accelerator in nuclear research. It can also be used in food and process sterilization, pasteurization, and as an alternate source of electric power. The main parts of a Van de Graaff generator are a belt made up of an insulating material, 2 pulleys, a lower pulley and an upper pulley, an electric motor, 2 metallic combs, spray comb and a collector comb, and a hollow metallic sphere. The belt carries the charge from the lower end to the upper end and moves over 2 pulleys, a lower pulley and an upper pulley. An electric motor is used to rotate the pulleys. Spray comb is held near the lower pulley. It sprays positive charge on the belt. Collector comb is held near the upper pulley. It collects the charge from the belt and transfers it to the hollow metallic sphere. The hollow metallic sphere is a large hollow conducting sphere which is supported at a suitable height over an insulating pillar. It receives the charge from the collector comb.